the evolution of computer languages, and how electricity started it all. Computers operate using a binary system with only two digits, 1 and 0, known as the base 2 numbering system. Think of a light bulb where on represents 1 and off represents 0. These binary digits, or bits, are the fundamental building blocks of all computer data. 8 bits form a byte, which can represent letters, numbers, or symbols. For example, the letter A is 010001 in binary. While binary might seem limited, it's incredibly powerful. By combining bits in countless ways, computers can represent any type of information. These on-off states are controlled by tiny electronic switches called transistors. A transistor acts like a gate, allowing electricity to flow, representing 1, or blocking it, representing 0. Modern processors contain billions of these transistors packed onto a single chip, enabling the immense processing power found in today's devices. In the early days of computing, programmers used machine code, the lowest-level programming language consisting of pure binary instructions. For example, a command to add two numbers might look like 10111011, 01010101, which tells the computer to fetch values, add them, and store the result. Programming in machine code was tedious and error-prone, as even a tiny mistake could cause the program to crash. To simplify this, assembly language was developed, replacing binary with mnemonics like ADD or MOV. While this made coding somewhat easier, it still required specifying every detail of a task. The need for more efficient programming led to the creation of high-level languages like COBOL, C, C++, Python, and Java. These languages use human-readable words and symbols, allowing programmers to write and understand code more easily. For instance, a machine code instruction to add two numbers could be written in Python as sum number 1 plus number 2. This shift from low-level to high-level languages revolutionized programming, making it more accessible and enabling the development of complex software. Each high-level language has its strengths. Python is known for its simple syntax and is widely used in data science, machine learning, and web development. Java is platform-independent and ideal for enterprise and Android applications. C and C++ are efficient and powerful, commonly used for system programming and large-scale projects. These languages provide abstraction, letting programmers focus on solving problems rather than managing binary intricacies. The evolution from binary and assembly to high-level languages marked a pivotal moment in computing, making programming more approachable and paving the way for modern software development.